Hello everybody, welcome to my channel. In this tutorial, we are going to learn how to create a Keras classification model using TensorFlow. So the libraries that we are going to use are sklearn and specifically we are using also the models of sequential and dense and activation as the layer, and as the optimizer we are using Adam. So let's jump in the code. At the beginning, I'm going to load all of the libraries necessary for creating the classification model. For the data, I'm going to use the predefined sklearn dataset, specifically breast cancer dataset, which is a binary data, which includes information about the different patients if they have breast cancer or not. So we can load it using load breast cancer data, and then we are going to see all of the data using data and the key of data. And for the target, we can have the access by using the key of target. Okay. So in order to see the dimension of our data, we can see we have around 569 observations with 30 columns. If we want to see the feature names of our columns, here there are 30 features. For now, I'm not focusing on the feature engineering part. I'm going to just focus on how to create the Keras model. In order to see also the target names, we can see that we are having two binary output, which are indicating if the user, the patient, is having a cancer or not. So, as the traditional approach of data science, we are splitting our data into training and testing. So, we are using the sklearn function as the input. We are providing x, which is which is not just only our training data, but the whole data set, the target variable. And then we are using 20% for testing and the rest for training. And then this is the random seed that we are using in order to fix the output of our model. So the output is going to be the data for training and the data for testing. So we are going to create our model by calling sequential as the basis of our model. And then we are going to add the first layer, which is including the activation function that we want to use, that we are going to use relu in this case. And we have to specify always for the first layer the number of the features, that for our case it's going to be 30. Okay. And then we are going to use 30 as the number of the nodes that we would like to consider for the first layer. Well, we can say that it is a good practice to always have the same number of nodes with the same number of input dimension. You can also change this part, but it's up to you. I always go with this default setting. And then we are going to use another layer, which is also dense, which means that we are having a fully connected layers with the same activation function and the number of the nodes 15. This part is also optional. I mean, the number of layers that you want to add to your network can be like random, not random, but it's like a try and error. I can add as many layers that I want. So in this case, since we don't have many data, I don't want to exaggerate. So I'm just staying with the option of adding the first layer, then the second layer, and then we are going to have the latest layer. Okay. So consider that for the second layer, we are not specifying input dimension, because we are not going to have the input. The layer is going to get the input from the previous layer. Okay. And this is the last layer, which we are going to have the output. So for the activation function, I'm going to use segmoid, and the number of nodes I'm going to use 1. And then we have to compile our model. So we have to specify what kind of optimizer we would like to use, the KPI that we are using for the calculation of the loss function, and the metric that I'm using is accuracy. if I call model summary, we are just going to see the schema of the models, okay? So we can see how many layers do we have and how many parameters is going to be used in the model. And in this phase, still our model is not executed yet, okay? What is going to execute our model is by calling model.feed. The model is what I have defined here. And we are going to specify the input data, which is xtrain and ytrain, which is the output of the train test split that we had here. And the other parameters that I'm going to use are batch size and epochs. Batch size means how many number of observations in each iteration of the training I'm going to use. So the model is using 16 observation as the first iteration, as the iteration for the learning. And I'm saying iterate 400 times. Well, let's decrease it to 200 for the training. And then, which means that my model is going to iterate 200 times by applying around 16 observation for the training. And then I'm going to use 20% of my training data for the validation. And I'm setting the shuffle as false, means that my training data cannot be shuffled. And I'm saving the result in the history. So it needs to run 200 times. That's what we are going to see here. And we can see in each iteration what is the output, what is the loss and accuracy, what is the validation loss and validation accuracy. So I think so far, so it is good. Yeah, we have to wait until it finishes the training. So this is going to happen around 200 times in order to be finished. And okay, it is finished right now. So in order to see the result, we have everything saved in the history variable. I can see it by calling history.history loss in order to see the loss performance. And for the validation, I'm going to use val loss. I'm calling PLT show in order to see the result. As you can see, we have near to 0 as the loss function. In order to see the accuracy and also the validation set accuracy, I'm applying marks on my array in order to see what is the maximum accuracy that I had. As you can see, we have around 92% accuracy in both test and validation, which is good. And then I'm going to evaluate my model by passing xtrain and ytrain. So we can see that the accuracy is around 93% with the loss of 0.15, which is not bad. And I'm going to, well, actually I have used the train data for model evaluation. So here I'm going to evaluate my model by passing the test data. So let's see. And as here we can see we have around 97% as the accuracy and the loss is 0.09. I think that's it. Here you have learned how to create a model using various layers of dense. And as you can see, the number of the nodes and the activation functions are the parameters that you have to specify. And you can do a trial and error, or you can use various methods in order to obtain the best number of nodes. And also, the batch size and epochs are another two parameters that you have to specify. So in another video, I'm going to teach you how to use cross validation by using the Keras model. Thank you and see you soon.